Hey guys, I hope all's well. I wanted to do 3 additional chain rule questions for you. I know we haven't gone over the homework yet, but if anyone is having trouble with the chain rule, these examples might be able to help you out a little bit. So I'm going to go through each of these 3. If you want to stop the video and try these on your own, you totally could. Or I'm just going to go through them, okay? So here's the first one. So the first one asks us to take the derivative of y equals 1 over the sine of x minus sine x. What I'd like you to think about here is there a way for me to rewrite this so that it's a little bit easier for me to solve? And here there is. How could I rewrite this thing? Well, what I can do, rather than trying to use the quotient rule here, what I can do is I can think about this as the sine of x minus sine x to the negative 1 power. And what the chain rule tells us is we're going to work through these step by step. So we're going to work from the outside function in. And hopefully it's kind of obvious to you guys that there are actually 3 different functions at play here. The first one is that all of this is being put to the negative 1 power. The second, as I work my way in, the second thing I'm taking is the sine of this whole x minus the sine of x. And the third thing, as I work my way all the way inside, the third thing at the third function as I work my way all the way inside is that x minus the sine of x. So let's go ahead and take this derivative. The derivative, which is y prime, is going to be negative 1 times this whole kit and caboodle, the sine of x minus the sine of x, to the negative 2 power. That's a really common mistake. Negative 1 minus 1 is negative 2. Times, now I'm going to work my way inside. I'm going to go to that green function that I circled there. The derivative of sine is cosine. And then finally, peeling away these layers, I'm going to step inside and I'm going to take the derivative of the x minus the sine of x, which would be 1 minus the cos of x. So what's my derivative? If I rewrite this thing is ugly, but I can rewrite it a little bit more simply. I'm going to write that 1 minus the cosine x out front. I'm going to keep a negative sign out front from that negative 1. I'm going to have the cosine of x minus sine x. And in my denominator, I'm going to have that sine squared of x minus sine x. All right, so there's your first one. That's your first example. Okay? Let's move on to the second. Okay, so moving on to our second example here. Again, this is a question we probably want to rewrite before we do it. And the easiest way to rewrite this thing is to rewrite this as the tangent of sine theta squared. The reason I recommend you rewrite this is I think it makes it a lot more obvious that now we're dealing with 3 different functions that are being composed. The 3 functions that are being composed are, there's an x squared function there, there's a tangent function there, and there's a sine function there. All those things are being composed together. So again, we're going to work from the outside in. The first thing I'm going to do is I'm going to take the derivative of this whole tangent of sine theta squared. One way to think about this is if I asked you to take the derivative of, if I asked you to take the derivative of that whole box, if I asked you to take the derivative of that whole box, all right, if I asked you to take the derivative of this whole box, let's try that again, squared. All right, that whole box squared would be 2 times that whole box to the first power, wouldn't it? So let's go ahead and put that down. So this is going to be, if I take this derivative, a little technical difficulty there. If I take this derivative, I'm going to have two times the tangent of sine theta to the first power. Now what am I going to multiply that by? What do I have to multiply it by? Well, now I'm going to step inside. What's the derivative of tangent? The derivative of tangent is secant squared. And that's going to get multiplied times the cosine of theta, which is derivative of sine theta. So this is y prime, the derivative is 2 times the tangent of sine theta times the secant squared of sine theta times the cosine of theta. Again, ugly, but doable. All right, last one. The fifth root of x tan x. Okay. Again, it's sometimes easier to think about these in a different form, so let's think about this as x tan x to the 1/5 power. Now when I take the derivative, this time I'm going to write it as dy dx, just to keep you honest. I'm going to take that 1/5 out in front, and this is going to be x tan x, and 1/5 minus 1 is -4/5. So remember, that's just me using this basic power rule. All right, it's n times x to the n minus 1. Now I have to multiply by what's inside. This is going to be times, and the derivative of that x tan x is going to be the derivative of the first, which is just 1, times the second, plus the first times the derivative of the second, which here is secant squared of x. This is really ugly, but we can simplify it a little bit. We can keep this as tan x plus x secant squared x. That 5 can go down in the denominator, the 1/5, the 5 can go down in the denominator. And this thing is the fifth root of x tan x to the 4th power. And so those are just 3 examples of some chain rule questions that you can look at, and you can give them a shot. Thanks.